Okay, folks, we're going to go ahead and get started. We're going to be doing conversions with two conversion factors. But the process is essentially going to be the same that we were using on Monday, in that we are going to determine what conversion factor we need based off of what unit we are given, what unit we want to solve for. And then we're going to find conversion factors that will allow us to do that. So let's just get into it. How many centimeters are in 23.5 hands? First of all, I noticed that the starting unit and the ending unit have nothing in common. They don't have a word in common. So we're going to be using our conversion factors from the top. I want to convert between 23.5 hands, and I want to convert that into centimeters. The first conversion factor that I'm going to find has hands in it. And when I find one with a hand, the one that I found right off the bat was 1 hand is equal to 4 inches. I chose this one because it had my starting unit involved. Now, what I noticed is once I had that starting unit involved, I wound up with inches, but I need it to be in centimeters. So I'm going to find a conversion factor, ideally, that has both inches and centimeters in it. And when you look up a conversion factor that has both inches and centimeters, you find 2.54 centimeters is equal to 1 inch. Again, I'm using this because it has the inches and it has the centimeters. Now that I have conversion factors that I can use, I'm ready to begin the problem. I'm going to start with the information I was given, which is the 23.5 hands. Hands needs to go in the denominator in order for the hands to cancel out. So out of this equality, the hand is going to go into the denominator and the 4 inches into the numerator. Again, that has to be the case in order for the hand to cancel out, and I'm left with inches. Now I'm going to use the second of my conversion factors, and the inch has to go into the denominator. So the 1 inch goes into the denominator, and the 2.54 centimeters goes in the numerator. The inch had to go into the denominator so that the unit would cancel out. When I key this into the calculator, I get a value of 238.76 centimeters. Now for significant digits. My original value has 3 significant digits. My first conversion factor, the 4 had only 1 significant digit, whereas the 1 in the hand is going to be considered an unlimited number of significant digits. Now for the 2.54 inches per or centimeters per inch, if you look at the document, it says exact by it. Because that is exact, the 2.54 and the 1 inch is going to be an infinite number of significant digits. The measurement with the fewest had 1 significant digit, so our answer could only have 1 significant digit. We would record this answer, therefore, as either 200 centimeters or 2 times 10 to the 2 centimeters. Questions? Let's look at another example. Let's look at 110 millimeters is equal to how many centimeters? This one has the term meters in common. Therefore, it's going to be your metric prefix conversion factors. Looking at the first metric prefix conversion factor, I need something with millimeters. According to the metric prefix conversion factor, 1 millimeter is 1 times 10 to the minus 3 meters. The other one that I need a conversion factor for is centimeters. According to the table, 1 centimeter is equal to 1 times 10 to the minus 2 meters. So basically, I chose these because I needed those specific units involved. Now, I'm ready to calculate. 110 millimeters. My millimeters must go in the denominator. So the 1 millimeter goes in the denominator, while the 1 times 10 to the minus 3 meters goes in the numerator. It has to be that way in order for the millimeters to cancel out. Now I'm going to use my second conversion factor. Of the second conversion factor, the meter portion must go in the denominator. So the 1 times 10 to the minus 2 meters goes in the denominator with the centimeter in the numerator. The meter portion had to go in the denominator so that the unit would cancel out. When you key this into the calculator, you get a value of 11 centimeters. Now we got to check for our number of significant digits. Our first value has how many significant digits? 2. That's because there's no decimal point showing, and therefore that 0 is not significant. How many significant digits do metric prefix conversion factors have? They're exact numbers, so they're unlimited. So all of this is unlimited. The measurement with the fewest was 2, therefore our answer must have 2, and it does if you just recorded it as 11 centimeters. Questions? I got a question for you. What would I have done if instead of 110, it had been 110 point? Everything would have been identical. Everything would have been identical, except when you got to the end, when you got 11 centimeters for your answer in your calculator, because your original number had 3 significant digits and everybody else had unlimited, you would have needed 3 significant digits in your answer. So yes, you are correct. You would have recorded it as 11.0 centimeters. Yes.
Why do we have to go through the meter?
Okay, the question is, why do you have to go through the meter? The answer is that there is a way you would not have to technically go through the meter, but it means you have to understand the metric prefix system. The way that I have set this up, every single one of these conversion factors goes through the base unit, in this case, the meter. Every single one of them does. And the reason for that is because it is my experience that class has probably been taught one or two different ways to do it. And I've seen mistake after mistake after mistake because they start to combine ways. So what I'm trying to get at is if you know exactly what you're doing, you don't have to go through the meter.
But if we not go through the meter, the answer is going to be like 1.1 because you just kind of divide it by time to the power of 2. Yeah.
If you hadn't have gone through the meter, you would have gotten, and you got 1.1, you would have gotten the answer incorrect. Because you did not take into account this is in millimeters, so you can't just jump straight to centimeters. You have to cancel out those millimeters.
I thought like 10, I thought it's like 1 times 10 to the negative 2 is, so 1 centimeter is going to equal to 1 times 10 to the negative 2.
Meters.
Meters?
1 times 1 centimeter is 1 times 10 to the minus 2 meters.
Okay. I just because I learned it before and then we talked 5 different ways. So I was like confused.
There are a couple of different ways you can do metric prefix. I'm not saying this is the only way, but what I have noticed is I have seen students get taught multiple ways to do the same thing and they confuse it all. Whereas this is one single, the idea is this is just one single way and it works. If you always go through the meter or go through the liter, it should always work to use just this conversion factor.
Because the way that we were taught is 1 millimeter is going to, no, 1 centimeter is going to equal 100 millimeters. That's why like we just take that value and we divide it to 100, you're going to get the answer. Because yeah, that's how we like learn in my country. That's why I'm confused when I get here.
It's 10 though.
It's
1 centimeter is 10 millimeters, not 100.
Yeah. Yeah.
So there are other ways, and what I'm trying to say is you don't have to use this method. I'm showing you this method because I'll keep it constant throughout the semester. And that way, if you had a mixed up experience, you can learn one method and you'll see it throughout the semester. Because many people have had mixed up experiences. Okay, let's look at another example. Actually, I'm going to give you one and see how it goes. When I'm doing it, what am I doing? I'm paying attention to the last unit and making sure it cancels out before I move on to the next unit and trying to make sure it cancels out. Let's see here. How many milliliters are in 6.34 pints? Pint is probably not spelled out as PT for short. I mean, it may be spelled out on the conversion factor. I don't remember how to do this one. Okay, so the first thing I would do is I was going to ask you, okay, you know, a lot of it was like I was saying, I found I was just like, and then I tried to take it aside. So I have that, but I just don't know. Okay, it's just it's not on that bottom. I was just looking at so many different options. I should
Okay, so 6.34 pints, and I want to convert that to milliliters. As somebody said, when you're looking up the conversion factors, there were a lot of pints, but there wasn't very many milliliters. So sometimes you got to work backwards and go, okay, I know that 1 cup is equal to 250 milliliters, how many pints are in a cup? And so 1 pint is 2 cups. And so sometimes you're not going to find a clear path. And so you have to go and find a conversion factor that you know you're going to need and try to work with it.
I have a question about 2. 2 is an exact number, so it is 1 sig fig.
This is 1 sig fig. So in this, you would have had 6.34 pints. The first conversion factor, my pints would have been in the denominator with the cups in the numerator, so that the pint would cancel out, leaving cups. And then in the second conversion factor, the cup would have been in the denominator with the 250 milliliters in the numerator. The cup went into the denominator so that it would cancel out, leaving milliliters. When you key this into the calculator, you'd have gotten 3,170 milliliters. Then you figure out your number of significant digits. Your first value has 3 significant digits. The 1 in the first conversion factor is considered unlimited, but the 2 would have only had 1 significant digit. The 1 and then the 250 would have had 2 significant digits. Our measurement with fewest was 1. So our answer should have only had 1 significant digit. And therefore you would have recorded this as 3,000 milliliters or 3 times 10 to the 3rd milliliters. Yes.
So
I got a question. Hold on.
So when we had 110 up there, we were talking about how the decimal place there, it would be 3 significant figures. So for this, because there is a decimal, do you need to worry about putting a new one in, or is it only if it's at the end and it's right?
On the previous one, the reason that the decimal place mattered is because, or the decimal point mattered, is because our conversion factors were exact quantities. So the conversion factors did not play into the significant digits. Whereas on this last one, the conversion factors also played into the significant digits. So that's why you don't have to enter a decimal point, is because you were only allowed 1 significant digit in this last one. And if I had to put a decimal point, I would have had 4. Other questions? Let me give you a couple more to do. There's one. And I'll come up with another one.
Yes, because they are both leaders, or hertz in the first one, and leaders in the second one. Yeah, focus on the unit. So over here, you would find mega, 1 mega. Measure 6. Oh, I've got spares, or you can take pictures. It depends on what it's going to be. So if you're talking about their first conversion factor, you would have 1 megahertz in the denominator and the 1 times 10 to the 6 hertz in the numerator. That's what we I don't know. We have this. And the next go up. And the next, well, you don't have to go over each thing. Each of them, look at the table. It's always 10 to the minus, or 10 to the power of z. Z here is hertz. So basically already 2 hertz.
So then the next one in the denominator would be what the terrace 1 times 10 to cancel out the hertz.
Correct.
For the world.
Correct. Yes.
This Terra is more than this is just try to do something. These are about hertz. These all equally
Yeah. So in this yeah. 12, right?
Yeah, that's well, yes.
Yeah. Yeah. I did one year. So that It'd either be this or it would be divided by 4. Or it's all Hey, because this is technically when it gets to that numerator. All of a sudden, right. Oh, I she told me she said it divides by yeah, you're close. Here's the thing. Yeah, I said not people think yeah, you can't use the words. 2.4 Oh, I see why. Because I have divided. And it's so how do we know we're supposed to oh yeah, so it's just I just want to make sure it's good. So I got this answer and I was wondering if it's Oh, okay. So but it's okay. We actually 6 times.
Tomorrow after.
This part.
So I think
Yeah. Okay.
Okay, folks, let me go ahead and throw these answers in because we're getting low on time. So it would have been 240.6 megahertz. When you look at your table, 1 megahertz is equal to 1 times 10 to the 6 hertz. Oh, I'm sorry, I dropped the 0 accidentally. One thing people are getting confused is Z in the table. Z is it's just a placeholder. It can be liters, meaning it would be an L. It could be hertz, which means it's HZ. It can be grams, which means it's a G. It can be, Z is just a placeholder. Now, since I'm in hertz, to get rid of the other one, I would have to do 1 times 10 to the 12 hertz is equal to 1 terahertz. And when you complete this, it comes out to be 2.406 times 10 to the minus 4 terahertz. The next one is 2.20 times 10 to the 3rd centiliter. According to the document, 1 centiliter is 1 times 10 to the minus 2 liters. And then we wanted to go to microliters. So 1 times 10 to the minus 6 liters is 1 microliter. So that would have been 2.20 times 10 to the 7 microliters. Now I will answer questions, but if you don't have questions, you're free to leave. But if you have questions, you can come ask me questions.